In this clip we'll learn the concept of a distance between vectors in an inner product space, and this builds on the concept of a norm which we just recently did. So if we have an inner product space and we take two vectors, the distance between u and v is going to be a non-negative number, and we're going to write it as like a function d of u and v, d for distance of course, and it's defined by the simple formula: the distance between u and v is the norm of u minus v. So let's get straight away to the examples. And this example is in the vector space R3 with the standard inner product. And let's take our two vectors to be u and v as follows. And we want to find the distance between these two vectors u and v. And by definition, that would be the norm of u minus v. And here we have to do a subtraction. 4 minus 3 is 1, 7 minus 5 is 2, minus 3 minus minus 1 is minus 2. And now we need to compute the norm of this. This looks familiar. I think we did this particular calculation in a previous exercise, and it came out 3. Oh, you know what? I'll do it again. So we take the square root of the inner product of it with this vector with itself. Standard inner product, so it's 1 times 1 plus 2 times 2 plus negative 2 times negative 2, and this is what we get. Square root of 9 is 3. That's the answer. So that's the distance between u and v. Now example 2, where we have the space of 2 by 3 matrices and the inner product. We've seen this before. A times b, we take the trace of b transpose times a. Let's take our two vectors, which are actually matrices, to be this and this, and we want to compute the distance between them. So the distance from a to b, by definition, is the norm of a minus b. And a minus b, we just do a subtraction. 10 minus 2 is 8, 9 minus 3 is 6, and so on. And the norm is the square root of the product of this with itself. And then we go to the definition of the product, which is the second one transpose times the first one, and the trace of that, of course. So let's see, the transpose of this, just write reverse rows and columns, and we get this. Now, multiply these two, we're going to get a 3 by 3 matrix, but we don't care about the whole matrix. We only care about the main diagonal, because we're going to take a trace. So I put asterisks, meaning don't care. We don't have to compute these. We just have to compute the diagonal. So here is, we multiply the 8-2 by 8-2. So it's 8 times 8 is 64 plus 4. And that makes it 68. Then 60 with 60, that gives 36. And then 4 minus 2 with 4 minus 2, so it's 16 plus 4, which is 20. And now we have to take the trace of this, so it's 68 plus 36 plus 20. And if we compute that, I think it comes out to 124. So we'll leave the answer like this. We don't need to do a numerical approximation. Square root of 124, a bit over 11. Okay, so that's this example.